Alright, and now we are going to talk about converting from binary to and from hex. Binary, lag here, to and from hex. This is actually one of my favorites because there's, I just hesitate to say trick, but it's kind of how it's designed and why hex is so useful. But the key thing, so binary is base 2 and hex is base 16. And an interesting thing is that 16 is 2 to the 4th. So we exploit this fact that 4 digits in binary is really 1 digit in hex. So remember, hex base 16, we have digits 0, 1, all the way down to 9. I always need this chart, so 11, 12, 13, 14, 15. Digits 0 to 15, we have A, B, C, D, E, F. Let's get a different marker. Let's go with purple. So you can take a base 2 number. So say we have 1, 0, 0, 1, 0, 0, 0, 1. Base 2. It's a subscript. So what you can do is, starting from the right, group together 4 digits at a time. Now you can convert those to decimal, just those 4 digits, and then convert that decimal to hex. So 4 digits in binary, remember, is 1, 2, 4, 8. So here we have 0 8s, 0 4s, 0 2s, and 1 1. So this is a 1. Here we have 1 8 and 1 1, which is a 9. Alright, and since 9 and 1 are the same in hex as they are in decimal, we would say 1 0 0 1 0 0 0 1. Binary is equivalent to 91 in hex. Alright, so that one not too interesting. Let's try a doozy. So let's switch pin colors again. Let's go green. Say we have 1 0 0 1 1 1 0 1 0 0 1 0 1. Binary. So again, you group sets of 4. And we have 1 left over, that's okay. So now we convert. So 0 1 0 1, that's 1 4 and 1 2. So that's 6. That's 1 8 and 1 2, that's 10. And this is 1 2 and 1 1, that's 3. And this is just a 1. Alright? But now hex, 10, we don't have 10 in hex. We can't have that as a digit. Alright? 10 is really an A. So we just take those. It's equivalent to 1, 3, A, 6 in hex. Very nice, very nice. And it, try another one, just for fun. 1 0 1 1 1 1. If you want, you can pause it, try yourself. But so group those. This is 1 8 1 4 1 2 1 1. That's going to be 15. And then this is just going to be 1 2. So 15 is really an F, like a 5. So this is equivalent to 2F in hex. And what's nice is it works the other way too. So you can go, so say you have a hex number like a 7 in hex. Alright? So A is really 10, 7 is really 7. So 7 in binary, again, you use up here. Alright, so 7 is going to be We'll even draw the things here. 7 is, we don't need any 8s, we need a 4 and a 2 and a 1. I do have to put the 0 there in the 8's place because you need all 4. 10 is going to be 1 8, 0 4s, and 1 2, 0 1s. So A7 in hex is really equivalent to 1 0 1 0, 0 1 1 1 in binary. Alright, so that makes it pretty nice. And I guess to go another, I told you in the last video, another way to convert from hex to decimal is you can take your hex and then convert it to binary like we did there. So if I wanted to convert this to decimal, first I convert it to binary, which we just did. 1 0 1 0 0 1 1 1 in binary. Now I convert the binary to hex, or not to hex, to decimal. So I want it in decimal. I don't know, what is this in decimal? So I do my placeholders. And we have the ones placed, 2, 4, remember just double each time, 8, 16, 32, 64, 128. So you have 128, and then 132, and then 1 4, 1 2, and 1 1. So that's 167. So you got all three, the hex, the binary, and the decimal. Again, really what this is used for is computers, because I mean, just a little application, since I know that's important to a lot of people. Computers, you know, you have a computer, or I guess most of yours is like phones, but anyways, a computer is just, the chips are all a bunch of switches. They're either on or off. So anything a computer does has to be converted to tell what the switch is, either to be on or off. So that's what binary is for. Right? We have on and off. So binary, typically 1 is on, 0 is off. So everything is converted to binary. Right? Numbers, pretty easy. We went through our decimal numbers. You know, you can write those as binary. We went through that. And again, you can see hexadecimal. Computers can convert that pretty easily too. It's just a lot more compact way to hold a number. Right? Dealing with numbers that have like 20 digits, you're going to need a lot of binary numbers, a lot of base 2 numbers, digits. So yeah, and even letters like M using the ASCII code, the American Symbolic Code, something. Right? M is stored as 77, which you can put as binary. I think 77 is, I looked this up, oh there it is, it's 4E in hex. And sometimes they write hex as a subscript instead of 16. Oh, that's ugly. Or it's 1001111 in binary. Alright, so any letters in any command, space, enter, anything on the keyboard gets converted to numbers to tell which switches. So it's very useful. Any computer science course usually learn a little bit about it, but because it's good to know. I mean, you can relate binary to logic too, you know, true or false. Things are true or false. So again, we'll probably talk more about some of that in class. You can always ask me questions. Alright, I think we're done.